Good morning all of you. In today's session of class 12 physics we are going to start a new chapter today. The name of the chapter is current electricity. So basically what happens is that suppose there is a conductor and you have managed to apply an electric field on this conductor. So E is the electric field which has been applied on this conductor. So the moment you apply the electric field, you know that the conductor has got free electrons. So all the free electrons will move opposite to the field. So you have applied one field, all the electrons will move opposite to the field like this. Now the thing is that when the electrons are moving, they will collide with each other, and also inside the conductor there will be some fixed cations. So the electrons will collide with these fixed cations and they will collide with each other. Now what we can say is that this is a process which will keep happening. Like the electrons will move opposite to the field, they will have collisions, they will slow down, again they will accelerate because of the field, again they will have a collision, again they will slow down, and this will keep happening. So if you consider a very long interval of time, right, then the average time between two collisions is called relaxation time. Okay? And this you will recognize, this is the Greek symbol tau. So this is the Greek symbol tau. Tau is the relaxation time. So it is the average time between two collisions of an electron. So basically the charge of an electron is small e and the field is capital E. So charge into field is the force, and force divided by mass is acceleration. So suppose an electron has just had a collision, so we can assume that immediately after the collision it will completely come to rest, and then it will accelerate with this much acceleration. So acceleration into time is equal to the velocity acquired by the electron. This velocity we write it as Vd. It is called drift velocity, right? It is called drift velocity. So what is the concept of drift velocity? It is the average velocity of motion of the electrons, because the electrons are having a certain average velocity with which they are moving against the electric field. So that average velocity, it is the drift velocity, that is acceleration into relaxation time. Now the thing is that suppose let us say that the length of the conductor from end to end is capital L, and you know that you have applied an electric field, but in reality what we do is that we apply a potential difference, right? So you are aware that what we actually do is we apply a potential difference. So we apply a potential difference between the two ends of the conductor. So suppose the potential difference between the two ends of the conductor is V. So potential difference divided by the length of the conductor is equal to the electric field. So V by L is equal to E. Right. Now let number of electrons per unit volume, let it be equal to N. Okay. Let the number of electrons per unit volume, let it be equal to N, and cross section area of the conductor is A. So number of electrons per unit volume is N, and cross section area is A. So if you multiply A into drift velocity into time interval, like suppose I am considering a time interval of motion. So if you multiply A into drift velocity into time interval, then this will give you the volume covered by the electrons in time delta t. So volume into number of electrons per unit volume, this is equal to the charge. So delta q is n into A into drift velocity into delta t. Now if you divide both sides by delta t, then you will get, okay, this has to be multiplied with the charge of an electron also. Yes. So area into drift velocity into time interval is area into length, that is volume. Volume into n is the number of electrons into the charge of each electron. So delta q by delta t is n into A into E into Vd. So therefore that is equal to the current. So current is NaEVd. So the current is N into A into E into Vd. Now, one very important thing, all of you, this relaxation time and this N, these are two very important properties of any conductor. So this number of electrons per unit volume N, it depends on the conductor. So if it is a good conductor, right, if it is a good conductor, then N will be high. If it is a poor conductor, then N will be low, right? So N depends on that, and relaxation time depends on temperature. So if temperature is high, then relaxation time will be less. If temperature is low, then relaxation time will be high. So what is the logic? Because if the temperature is high, the frequency of collision will increase, so they will collide faster, so the relaxation time will be less, and if temperature is low, relaxation time will be high. So these are the things: relaxation time and number of electrons per unit volume, how it is related to temperature and the properties of the conductor. Okay, now coming back to current is equal to N into A into E into Vd, coming back to this equation, what we will do is that we will now write N into E into A into E into capital E into relaxation time So this is the equation: N E square tau by mass into field into area. Now this N E square tau by mass, this is called conductivity. Okay, this is called conductivity. This is the symbol of conductivity. this n e square tau by mass, this is called conductivity, and this is the symbol for conductivity. And you know that as I told you that the electric field is given by V by L. So ultimately V will be I into L by A into 1 by sigma, and 1 by sigma is called resistivity. This is the symbol for resistivity. So 1 by sigma is called resistivity. So V is equal to capital I into R. So rho L by A is actually called resistance, right? So rho into L by A, this is called resistance. So you have the proof of Ohm's law. So this is the proof of Ohm's law, right? So this is the proof of Ohm's law. Okay, so this is a very important part of the chapter current electricity which we have done today. Now your homework is that you have heard from me that these two are the most important parameters, relaxation time and number of electrons per unit volume. Now your homework is you will have to make a chart your homework is that you will have to make a chart that you write number of electrons per unit volume, you write relaxation time, and then you write conductor, semiconductor, insulator, and here you will have to compare the values. Like for example, conductor you can say that n is highest, suppose, then insulator lowest, something like that. And similarly relaxation time, so highest and lowest. So you have to complete this chart. This is your homework, and you can submit your homework by 9 PM tomorrow as always. Thanks a lot. I'll end the session. Bye all of you.